Marco, how are you?
Good, thank you. Very well, thank you, Chandler.
Good. I'm glad to hear it. For our viewers, I've been trying to do some interviews to help kind of get a little bit of a deeper dive into the case studies that we already have, talk to the researchers face to face, understand what's important to them, the projects that they're working on now, going into the future. Who we have today is Marco. He works on some really cool projects out in the Red Sea right now. We're going to talk about that and expand on that a little bit into his future projects. Marco, go ahead and introduce yourself, talk about your education and some of the research you're working on.
Yeah, so I'm Marco Fusi, and I'm currently employed as a research associate at Napier University in UK. But I've been get my degree in Italy in natural sciences, and then I extend my education getting a PhD in microbial ecology and in tropical and subtropical environments. And then I end up to do a postdoc research at KAUST University in Saudi Arabia. And that is how get involved in the several studies in the Red Sea.
That's it. So you've been everywhere in your pursuit for education and research.
I did quite a long road from Italy down to Africa, and then Saudi Arabia, and now back in Europe, in UK.
That's incredible. So you mentioned the Red Sea. Let's go ahead and take a little bit of a deeper dive into what this case study that can be found on www.pme.com, the case studies page. Let's go ahead and take a deeper dive into that specific research and kind of see what you guys found with using the Minidot.
So basically, the Red Sea is quite an harsh environment where to live if you're an aquatic animals, because there is one of the hottest sea in the world, and it's quite oligotrophic, so there is not so much nutrients there. But the Red Sea hosts quite a unique environment and coastal environment made up by coral reef, mangroves, and seagrasses, where a lot of an astonishing amount of animals and species is living in there. So during my education and my research, I've been always focused about the effect of climate change on aquatic animals, and the effect on temperature and temperature rise on the physiology and the performance of animals. However, if studying the Red Sea, I saw that in this coastal environment that is the main object of my studies, temperature rise very well above the thermal limits of a lot of animals, like, for example, swimming crabs or sea cucumbers, sea stars, and other animals that live in this ecosystem. So we were searching a lot for this reason and why this animal can tolerate higher temperatures. So most of the work now in climate change science has been done just taking the variable by itself, studying only temperature, studying only pH, on only oxygen, and in this case, hypoxia, because a lot of work has been done in hypoxia. But if you think about the Red Sea that has crystal clear waters, and a huge and rich community of organisms that photosynthesize, like algae, coral itself, because the coral hosts symbionts that are algae, and then during the day they produce oxygen. Mangroves, plants that host in the roots other primary producer, algae and other bacteria that produce oxygen. So basically, we test the idea. We were going to measure if in this environment with all these primary producer, which is the oxygen variation during the day. And we found that all along the coast, and especially in the coral reef, at the layer of the corals or at the layer of the algae, during the day, even if there was a high temperature that go beyond 40, 45 degrees, there was a huge amount of oxygen there. For example, we measure in the coral reef that some days you can reach up 300% of oxygen saturation. So basically this ecosystem made up a super saturated environment and provide the animals a huge reservoir of oxygen that we measure by using the Minidots. So the advantage to use the Minidots is because they are quite easy to use, and they are quite robust in different conditions. And they work quite well for long period of logging. So what we did in this study, we used the Minidot together also with other loggers to record the entire years of oxygen and temperature variation. And we record this daily cycle of oxygen supersaturation that help the animal to overcome the or to cope with, I would say, the hot temperature that there are, especially during the day. So we found that this interesting pattern that supersaturation determined by the heavy presence of primary producers help the animals that live within this ecosystem made up of primary producers to cope with high temperature.
That's an incredible environment that they have to endure. I'm curious if the supersaturation of oxygen is enough to provide and keep this environment stable through the night as well. I mean, I would assume so, but what are there significant drops where they're scraping by at night and it comes back as photosynthesis kicks back up during the day? What kind of fluctuations are we seeing with that? I'm interested.
So basically, you are recording an average 200% during the day and close to zero during the night. But
wow,
during the night, you have lower temperature as well in shallow water. So of course, the animal do not need all the oxygen to cope with high temperature because they don't have high temperature. The other interesting thing is that daily, during the day, the hyperoxia that they experience, they help them to cope with the hypoxia they are going to face in the night every time of their life. So it's quite this cycle of oxygen indicate us two things. First of all is that the coastal environment are quite heterogeneous. It's quite variable in the day in terms of oxygen. The second is that the animals do not live in a constant environment, but they every day cope with a very low amount of oxygen during the night and a high level of oxygen during the day, thanks to the activity of the photosynthesizing organism. And this is quite important if you think about the climate change, because this means that protecting the coastal environment can provide can be one of the solutions that we can adopt along our coastline to protect the animal from the rising of temperature.
So we've covered a lot about your research and what we're trying to accomplish, and even a little bit of some of the data that you guys have been able to recover. I'm curious exactly how the Minidot aided you guys. In the case study, I read that you guys were deploying them 1 to 2 centimeters above the floor of the Red Sea. How did that come into play? Am I correct in saying that?
Yes. So basically, we put the Minidots close by the surface of the sea bottom, where you have the photosynthesizing layer of primary producers, and where the animal lives. Of course, if we record for example, the oxygen in the 2-3 meters water is not actually ecologically relevant, because animals do not stay on the surface, but they stay closely in association with the benthic environment. For example, swimming crabs has the holes, the burrows within the seagrasses or within the roots of the mangroves environment. And for example, on the coral reef, we just attach the Minidots to the coral system. So we record which is the actual level created by the coral reef itself, basically during the day. So the deployment was quite easy because we can easily find place where to anchor the Minidots. And so we do by diving in the coral reef or by snorkeling in mangroves and seagrasses.
That's amazing. Could you explain a little bit exactly how you guys anchored it? Was there like maybe rebar, or did you guys have some type of anchor point and tie off the Minidot?
So in the mangrove is quite easy because the mangrove itself is a stable anchor for the Minidots. So we just tie firmly the Minidots to the root system, and it was quite stable. In the seagrasses and in the coral reef, we used a huge metal bar to have a very solid base of anchor. And around KAUST University, that is just on the Red Sea, we have a lot of study points where already this location point was arranged, so we did not impact on the ecosystem itself, because already there was this metal bar ready to attach sensors for recording and for other experiment. The same in the seagrasses. We have this beautiful lagoon along the coast of the Red Sea, and we have already some station made by the solid base of metal where we can attach our sensor and study the environment around.
That's pretty convenient.
Yes.
Okay, I gotcha.
This is the advantage to work in let's say, in such a university that is just on the sea. You just have everything there and everything set up for your measure and experiments.
That's really cool. I'm curious, are you guys expanding this research at all in any other locations, or asking any other questions, or conducting any other research with the Minidot?
Yeah, so this phenomenon of supersaturation was well known even before. So what we did is just we link the supersaturation phenomena to the physiology of the animals. And is somehow a sort of other exploring the other side of the coin. So basically we know that hypoxia and hypoxic event is more frequent with climate change, but nobody went to see which is the effect of supersaturation, and the effect on the physiology of the animal. So it's a sort of feedback that we found. It was quite interesting and well received from also the journal that we published this research. So what we did, we expand the area of our interest, and we try to test if in other systems like Mediterranean Sea, taking some location, like interesting location from the scientific point of view, for example, the Lagoon of Venice, that is really richly colonized by primary producer. There is a huge forest, meadows of seagrasses, for example, there. And also in colder sea, is to test if the supersaturation is happening at higher latitude, like in the UK, in the North Sea, in Scotland. And we established this collaboration, and we're now using the Minidots to test and to see which is the fluctuation of supersaturation in these other two different environments. And surprisingly, what we are finding is that although our colder sea than the Red Sea, this phenomena is happening and is constant and predictable, since it's daily, it's changing on a daily basis. And of course, it's depending on the season. But so what we are scraping off is just the point tip of the iceberg of the supersaturation, and we try to see which is the magnitude of the supersaturation at different latitude and the effect on the animals that live in there. So this will be our next next step. And there is another direction that we are taking, and is about the freshwater ecosystem. So as the marine coastal ecosystem is rich and diverse in photosystemic, in organism that do photosynthesis, so also the freshwater environment do. And we are testing the variation of oxygen within this environment, and then the consequence for aquatic, freshwater aquatic life.
I'm really excited to hear back at some of that data. And it
Yes,
sounds like you're doing some...
Hopefully soon.
Is there a timeline for that, or is that still kind of in the works?
So we hope to submit soon the paper on the 3 locations for the coastal environment, and soon, relatively soon, the freshwater experiments.
Now, for the Red Sea, you do have that information, and you said it was published in what journal? Could you tell the audience what journal that is, just so they can kind of do a little bit of a deeper dive themselves into your work?
Yeah, so all data that we retrieve from the Red Sea are published in the Science Advanced paper. That is, there is the link on the page on the Minidots case of study. So whenever one is interested, they can go and download the data from the journal, or can write to me as corresponding author, and they can provide the data.
Well, that's fantastic. I'm really happy to hear about your work and how you're expanding your research. I'm glad that the Minidot can help you do this, and I hope that it continues to help you and make your work easier. And I'm really excited to hear what more information we have to come.
Yeah, so basically the idea is we now, with all the Minidot deployed around, how can I say, to create a larger database with a lot of case studies to deeply analyze these phenomena of supersaturations.
Well, that sounds fantastic. Marco, thank you so much for your time. I really appreciate you. By the way, there is an 8-hour difference between Marco and I. We started at 9:30 a.m. my time and 5:30 p.m. his time, so he's finishing his day. I'm just starting mine, but I really do appreciate you taking a little bit of time out of your day to talk to me. Thank you, Marco.
No problem for that. Thank you very much to you.